Hello, this is Dr. Caroline Peterson coming to you from Natural Women's Health Institute in Sarasota, Florida. My patients have been asking me for advice about the GLP-1 receptor agonists and their use. People will generally call these things like semaglutide, Wegovy, Ozempic, things like that. And so what I thought is that I would talk about how the body naturally produces and uses GLP-1 and what the difference is from the way the drug impacts the body. And so that's what we're going to talk about today. So GLP-1 is an amino acid hormone that's produced primarily in the intestine, particularly the end of the ileum and the colon. However, it is also produced many other places in the body. It has many functions, but insulin signaling is one that people will think of off the top. The way that it's designed is that it becomes active and has a very short half-life because it is readily inactivated by DPP4, which is an enzyme. And so it's activated and almost immediately deactivated. So it works very quickly. The half-life is 1 to 2 minutes. And very little of the GLP-1 produced in the intestine goes into systemic circulation. And so this is something that we want to keep in the top of our mind. Okay, the body is designed to have very brief exposure to GLP-1, not for a day, not for a week, not for years on end. This is the design of the body. What is a peptide? So GLP-1 is a peptide hormone, and a peptide is a short chain of amino acids. Amino acids are the building blocks of protein. So, so this is a hormone, a protein type of hormone. And these peptides are used in our body for lots of different things, like regulating blood pressure, uterine contractions, and of course, blood sugar regulation. That's what we're thinking of today. So after eating, we'll see the first peak of GLP-1 within 15 to 30 minutes. And then there's another peak 45 to 60 minutes after the meal. And then we'll have that decrease. The things that stimulate GLP-1 production are glucose, which is sugar, fructose, which is fruit sugar, fats, like those found in nuts and seeds, avocados, fish, and animal products, olive oil, other vegetable oils, and then some proteins. The greatest bang for your buck for GLP-1 production is eating lipids that are combined with sugar and amino acids. So basically fat, carb, and protein. We should have that with our meals. So that's a good way to eat. DPP4 is the peptide that breaks down GLP-1. It breaks down proteins. GLP-1 is a protein hormone, so that makes sense. And so it's gonna want to break that GLP-1 down at where the hormone has an alanine or a proline amino acid. So that's what we're going to be thinking of when we're thinking of the drug. What did the drug do with alanine and proline? So the way the body's designed is that when you eat, you eat food. Food has glucose in it typically. And so then you're going to have an increase in sugar in your body. That's the fuel the body runs off of primarily. So when you have that increase in glucose, that's going to go to the pancreas, and the beta cells in the pancreas are going to be stimulated to release insulin. That insulin is going to go to the liver to stimulate storage of, of glucose for later. And it's also going to go to the cells to stimulate the cells to take in that glucose as fuel. And then through these two processes, we're going to have the glucose levels go back to normal in the blood. When you have a decrease in glucose in your blood, that's called hypoglycemia. And that will stimulate the pancreatic alpha cells to release glucagon, which then goes to the liver and then converts that stored sugar into active forms and release that into the blood so that you can have a normal glucose level. So the body has a system for what to do if there's too much sugar in the blood or too little sugar. So GLP-1 stimulates insulin secretion from the beta cells in the pancreas. It inhibits glucagon secretion. So that's from the alpha cells in the pancreas, and that's the one that makes you store sugar in the liver. It suppresses your appetite, and it makes your gut kind of slow down so that you can have distension or just bloating, you feel full. And then it also has an effect on inflammation, a positive effect on inflammation. It decreases inflammation. That's what GLP-1 does in general, overarching. So we've talked about GLP-1's influence on the pancreas so far, the beta and alpha cells, but it has extra pancreatic effects also. It reaches beyond the pancreas. It also impacts the gut itself, the kidneys, the nervous system, especially the central nervous system, the brain stem, the heart, and the immune system. So in the body, in the wisdom of the body, which in natural medicine, we don't want to think we know better than the body. We just want to study the body and say, you know best, even if we don't understand. We don't want to countervail the design of the body, because in our idea, the body is wise and we want to play into the strength of the body to help it. So in the wisdom of the body, where there is GLP-1 production, there is also DPP-4 production to quickly break down that GLP. That's the rule. That always happens. And so one way you could think about it is that these two things occur together because the body is designed, the body mandates a short half-life for GLP-1. For some reason that we may not understand, the body only wants short-term exposure to GLP-1. And so in our way, in natural medicine, of thinking about this is that even if we don't understand it, we want to maintain that. But where is GLP-1 produced? So mostly it's produced in the distal jejunum and the ileum, in the L cells, inside of the intestines. Some is produced in the brainstem, some is produced in the brain, some is produced in the taste buds, and some is produced in the pancreas. The L cells are where most of the GLP-1 is produced in the body. And this is part of the enteroendocrine system. So entero means gut or intestines. Endocrine means the part of your body that sends signals through the blood. And so this is where the incretin hormones are produced. So those are the ones that have to do with appetite and digestion, the sense of fullness and things like that. In the brain and brain stem, the GLP-1 also is produced and has an impact on food consumption, metabolic rate, and glucose use. It acts as a neurotransmitter and is very protective of the nervous system. So, so it's a positive thing to have exposure to GLP-1 for the nervous system. It crosses the blood-brain barrier, and so it's a small molecule. In the brain, what we see is that this small study of 30 human brains, in the way they studied it at least, there's a decrease in age-related GLP production after age 40. And in the prefrontal cortex and the brainstem, they were not able to find any GLP-1 after 60. However, I think these were preserved samples, and so we have to take it with a grain of salt. It's hard to know what's happening in a live person based on a study like this. But in general, the idea is that probably there's not as much as we age, but who knows what that means. In the taste buds, types 2 and 3, there will be GLP production. And this production has only a local effect. In the taste buds, we'll see GLP production with natural and artificial sweeteners, umami flavors, it's like savory flavors, long chain fatty acids like olive oil, fish, nuts, avocado, meat, things like that. Bitter is another huge reason that GLP-1 is secreted in the taste buds. And also the intestines. Bitter receptors throughout the whole GI tract, from your mouth to the anus.